Hello learners, welcome. Today we are dealing with topic 2 of Form 4. The topic is called Chemistry of Energy Changes in Physical and Chemical Processes. We are in lesson 1. We start by defining energy. What is energy? Energy is the ability to do work. And remember, energy is measured using kilojoules. Energy is measured using kilojoules, which is written Kj as the chemical symbol. There are many forms of energy, such as chemical energy. We're having electrical energy, heat energy, kinetic energy, and also potential energy. Energy can neither be created nor destroyed, but can be converted from one form to another. For example, heat energy can be converted to kinetic energy. Next, we are going to go to endothermic and exothermic reactions. Let's start with endothermic reaction. What is an endothermic reaction? Endothermic reaction is a process or a reaction that's accompanied by the absorption of heat. For example, when ammonium nitrate is dissolved in water, the solution formed has a lower temperature than water. This is because heat energy is absorbed in the process of dissolving. So that means an endothermic reaction is a reaction that's accompanied by the absorption of heat, and it results in a decrease in temperature. That's why we are having the solution formed has a lower temperature than the water. Okay, the reactants and products in a reaction form a system. In an endothermic reaction, the system absorbs heat energy from the surrounding. Therefore, it will lead now the products to have a higher energy content than the than the reactants. Okay, let's just have the energy level diagrams for endothermic reaction. Energy level diagram. When you're drawing an energy level diagram, we have this one for the general energy level diagram for an endothermic reaction. You're supposed to have the x-axis as reaction pathway or reaction progress, or you can have even reaction path like that. Then on the y-axis, you are supposed to have energy, and energy is measured using kilojoules. So here we said earlier on, the products have a higher energy content than the reactants. That means the reactants are placed on the lower side of the y-axis because they are having a lower energy content when compared to the reactants. So the reactants will be on the lower side, then the product will be on the upper side, then the arrow will go from the reactants towards the products, and the enthalpy change there will be positive, because when you're looking for enthalpy change or energy change, we are told energy change is given by enthalpy of products minus enthalpy of reactants. For example, if you check here, the energy of products are higher. For instance, if we take the energy of products to be maybe 90 kilojoules, and the energy for the reactants, because they are down here, we take it as 16. If you subtract 90 minus 16, you are going to get 474. That means 74 kilojoules will be a positive there. So we are going to have the enthalpy change there will be a positive because products are having a higher energy content than the reactants. So the positive change will be the energy taken in. Okay, to have this example, when ammonium nitrate dissolved in water, it is energy level diagram looks like this. We have the reaction path or reaction pathway or reaction progress, and here we are having energy, which is measured in kilojoules. So our reactants are placed on the lower side, or they are having a lower energy content, so they will be down here. Ammonium nitrate, which is solid, dissolved in water, which is liquid. We are going to get a product called ammonium nitrate. Remember, we said in endothermic reaction, the products have a higher energy content than the reactants. So here is having a higher energy when you compare with this side of the reactants. So that means we are going to have a positive 25.8 kilojoules as the energy taken in when ammonium nitrate is dissolved in water. So let's go to the exothermic reaction. So if you know endothermic reaction, you also know exothermic reaction. So what is exothermic reaction? So it is the opposite of endothermic reaction. So this is a process or a reaction which is accompanied by the production of heat. Remember, when we are dealing with endothermic reaction, we said is a process or a reaction that's accompanied by the absorption of heat. So exothermic reaction will be by the production of heat. Remember, we said example of endothermic reaction, we have taken ammonium nitrate dissolving in water. So here we're taking when sodium hydroxide dissolves in water, the solution formed has a higher temperature than water. So we can say exothermic reaction is a reaction that's accompanied by the production of heat and results in an increase in temperature. So reason is because heat energy is given or is released in the process of dissolving, or you say heat energy is given out in the process of dissolving. Okay, what about when comparing the energy content in the reactants and the product for an ectothermic reaction? We are told the reactants and products in a reaction form a system, and in exothermic reaction, the system releases or gives out heat energy to the surrounding, which makes now the products to have a lower energy content than the products, than the reactants. So what have we said about endothermic reaction? We said the products have a higher energy content than the reactants. So here it's the opposite. The products have to have a lower energy content than the reactants. So to draw the general energy level diagram for an exothermic reaction, the reactants will be up because the reactants are having a higher energy content than the reactants. So than the products, So the products will be down here because they're having a lower energy content, then the reactants are up there. That means the enthalpy change that we are going to get will be negative because, for example, if our energy in our reactant are maybe, let's take 46 kilojoules, and the one for products is 3 kilojoules. So that means if you want to get the heat change is given by energy of, we have written here, we can get energy change or heat change is given by enthalpy of product, which is 3 in our case, minus enthalpy of reactants, which is now 46 in our case. We are going to get negative 43 kilojoules. So that means the enthalpy change there for an exothermic reaction will be negative. So for example here, for us to draw the energy level diagram for the dissolution of sodium hydroxide in water, looks like this. We're having reaction path or reaction pathway or reaction progress. Here we're having energy, which is measured in kilojoules. So we're having sodium hydroxide dissolved in water as our reactants. Then the product will be sodium hydroxide solution. That means the enthalpy here for sodium hydroxide solution will be 43 kilojoules. So this is now the energy released or the energy given out when sodium hydroxide dissolves in water. Then lastly, let us go to enthalpy notation. What is enthalpy? Enthalpy is the heat content in a chemical. It's assigned by the symbol H. So enthalpy change or energy change is a change in heat content, and it's denoted by delta H. So when you see delta H, that is a change in an enthalpy change or energy change. So the enthalpy change during a reaction is given by the expression. That's enthalpy change or energy change, which is delta H, is given by enthalpy of product. That is EB minus enthalpy of reactants. That is ER. That's the end of our lesson.